So let's talk a little bit about reference angles. So these are angles that are formed between, you could view it as the terminal ray of an angle and the x-axis that is positive and acute. And we usually denote it with a theta prime. Now you might say, why do we even need this thing called a reference angle? And you'll see as we expand our definition of trigonometric functions, this will be very useful for being able to evaluate different trigonometric functions to really extend what you already know about them. So let's just conceptually think about the reference angles in each of these situations. So here I have an angle that's in the first quadrant. It's a positive and acute angle. And so it's a positive acute angle formed with the x-axis. So here's a situation where this is also going to be the reference angle. So theta is equal to theta prime. So if this was, for example, a 45-degree angle, well, the reference angle is also 45. If we were to say this in terms of radians, if this were pi over 4 radians, then this will also be the reference angle. Now it gets a little bit more interesting when we go into the other quadrants. This here is in the second quadrant. So what would be the positive acute angle formed with the x-axis? Well, it would be this right over here. That would be the reference angle. Now, how would we compute it? Let me make that clear. That's a prime right over there. How would we compute that? Let's say if theta, in this situation, theta is equal to 130 degrees. Well, in this case, the reference angle is taking us all the way to 180. So it's going to be 180 degrees minus that. So I will write theta prime in this situation is 180 degrees minus 130 degrees, which is equal to 50 degrees. This is a positive acute angle between that, we could say that terminal ray and the x-axis. And as I said, this will be useful in the future when you're trying to evaluate trig functions, or where that extension of your current definition of trig functions come from. Let's go into the third quadrant, and we could have done this with radians as well. Actually, maybe I'll do this example in radians. So here we have, here we have an angle that gets us into the third quadrant right over there. And what would be the reference angle? Well, the reference angle, once again, it's an acute positive angle formed with the x-axis. So acute positive angle formed with the x-axis would be this right over there. Now let me construct a theta in radians that matches. So we know that this would be, if we're pointed this way, we're at 0 radians. This is pi over 2. This is pi. This is 3 pi over 2. And so if I had, we could view this as 2 pi over 2. So we could view this as maybe 2.5 pi over 2, which is the same thing as 5 pi over 4. So if theta in this situation is equal to 5 pi over 4, what would this reference angle be? Well, it would be this minus either 180 degrees if we were thinking in degrees, or minus pi. So here, our reference angle, theta prime, is equal to 5 pi over 4 minus pi, which is the same thing as 4 pi over 4. And so this will be equal to pi over 4. That is our reference angle, positive acute angle with the x-axis. Now, last but not least, we are in the fourth quadrant. What would our reference angle be? Well, it would be this right over here, positive acute angle with the x-axis. And let me give you an example. Let's say that theta here is 340 degrees. I'm switching back to degrees now. Well, theta prime, it would be what takes you all the way to 360. So theta prime is essentially going to be 360 degrees minus 340 degrees, which is equal to 20 degrees. So hopefully you have a sense of how to compute reference angles, what they are conceptually, and you'll see in the future this will make it much simpler to evaluate trig functions conceptually.